Today, on how it's made. Laminated wood beams. Sport utility vehicles. Veggie burgers. And wood boring augers. In architectural design, exposed wood beams use the structural components of a building in an aesthetic way. These beams are often made of glued laminated timbers. They're constructed by gluing together several layers of lumber and forming them into a particular shape, such as a curved arch. These beams look as though they're a solid piece of wood. However, they're actually laminated wood, several boards of lumber glued together to form one piece. The boards aren't layered haphazardly. Rather, the top-grade wood goes on the top and bottom, where the beam must be the most resistant, and the lower-grade wood in the middle. The boards are far shorter than the finished beam. Therefore, the first step is to extend each layer to the required length by connecting several boards end to end. To do this, a conveyor system transports 10 boards at a time to a mill. Saw blades trim the edges to make them perfectly square. Then revolving knives cut finger joints on both ends. When it comes time to connect the boards horizontally, the finger joints of one board will fit neatly into those of the next. The comb-like shape of the finger joints creates a far greater surface area to glue compared to leaving the edges flat. More glue makes for a stronger bond between boards. The glue is high strength and waterproof. It goes on brown but dries translucent. Workers line up the glued boards in a machine called a crowder. The machine's pressure rollers slide one board into the other, interlocking the finger joints. Then two plates clamp down on each joint, rendering the adjoining boards flush, should one be sitting slightly higher than the next. About 15 seconds of heat cures the glue. The connection is barely visible because the glue dries translucent. Now that each layer is the required length, it's time to adhere them vertically to make the beam. First, a glue applicator coats one side. Then workers turn the layers on their sides and stack them in a steel frame called a jig. Once they've stacked the required number of layers for the beam, they activate high-strength steel pressure vices. These apply high pressure for 6 to 8 hours until the glue between the layers has cured. To make an arched beam, it's the same process, but they stack, then clamp the layers in a curved jig. Once the glue cures, this laminated wood beam is stronger than solid wood. However, there are still several more steps to go. A two-sided planer simultaneously finalizes the dimensions, evens out the ends, and removes excess glue that oozed out under pressure. Next, a computer-guided multi-tool machine cuts, drills, and notches the beam according to the customer's technical drawing specifications. Then each beam gets a tag indicating the order number and part number. In the final finishing department, workers sand away any visual defects and smooth the surface in preparation for staining. Finishers apply one coat of wood stain with a roller, then work it by hand to ensure uniform absorption throughout. Once the beam is shipped to the construction site, the customer might apply a flame-proof coating, which would significantly slow down the rate at which the beam would burn in the event of a fire. The customer may also stain it a deeper shade to match existing woodwork. The four-wheel drive utility vehicle was originally designed for war. It was World War II, and the American-made military Jeep quickly earned its stripes, plowing through mud and muck on the road to victory. Today's SUVs are modern versions and prove that the concept has transitioned nicely into civilian life. When the road ahead is rough or disappears entirely, a four-wheel drive utility vehicle keeps on going. Production of this custom SUV begins with the mandrel bent frame, made of thick steel rails. A worker welds brackets to it for attaching parts. This one is for a shock absorber's nitrogen tank. He attaches a link for the sway bar and suspension arms. He then welds super thick braces for shocks to the front of the chassis. He measures the space between them to confirm that there's adequate clearance, and then fits heavy-duty calipers over the brake rotors installed at the front. The front brakes are a 6-piston system for extra stopping power. He now fits the coil-wrapped shock absorbers to the front axle and bolts them to the braces we saw welded to the chassis earlier. This is a preliminary installation. The parts will all be tightened more precisely later. It's time to give this custom SUV some supersized wheels. He positions the rims on threaded bolts protruding from the axles and then secures the installation with lug nuts. The tires are 8-ply with deep tread for off-road traction. This SUV chassis is ready for power. The team wheels the chassis under the 8-cylinder drivetrain and carefully lowers it into position. This powerful engine will generate a lot of heat, so it needs a large capacity radiator to keep cool and prevent damage to the engine. Once the steel chassis has been coated with a protective finish and the fuel system has been installed, production shifts to the next stage, piecing together the SUV body. This pre-assembly will ensure all the aluminum parts fit together flawlessly. After this, the SUV will be completely taken apart for painting and then put back together again. He hinges the doors to the body with thick steel pins that hold up to wear and make the assembly easy. He attaches each window frame to the lower door panel and checks the fit. Any gaps could allow the wind to whistle into the vehicle. He confirms the parts align and that the door latch works. He bolts the steel roll bars to the SUV body. Once he's satisfied that the framework meets all the specifications, he'll take it apart. The paint is a powder coat finish. It's ionically charged, so it gravitates to the negatively charged parts as it's sprayed. Once baked in an oven, the coating forms a skin that's tougher than conventional paint. They also coat the underside of the lower parts with a heat-cured finish to reduce wear and to muffle vibration. They now piece together the lower body of the SUV and assemble the dashboard and the instrument panel to the front. They bolt the seats to the floor, and once other parts have been welded to it, they lower the assembly onto the chassis. The chassis has by now been completely wired. The parts mate perfectly. It takes about 250 person-hours to build one of these custom SUVs. We've shown just the highlights. When it's complete, they test everything from the sensor-activated step to the windshield wipers. Once they confirm that all systems are operational, this SUV is ready to hit the back roads. High off the ground with four-wheel drive, it's equipped for whatever lies ahead, and there's sure to be a few bumps along the way. Craving a burger but yearning for a change? The veggie burger is a lower-fat alternative to the beefy favorite. Just hold the fries. Developed in the early 1980s in London, England, the veggie burger has gone from fringe food to the mainstream, all in short order. Just add a bit of oil to the grill and this meatless patty sizzles with burger appeal. Chock full of grains, nuts and veggies, it somehow looks kind of beefy, but it tastes distinctly different from an actual meat patty. This particular burger is a non-soy version, but there are many kinds of veggie burgers available today, and an increasing number of people go meat-free or reduce the amount of meat they eat. They start with finely minced frozen veggies. This recipe calls for carrots, celery, onions, and mushrooms. And that's safflower oil in the dish on the lower left. The safflower oil simmers on the bottom of the steam-heated mixer as they gradually add the ingredients. Blades stir the mix as it sautés. As the vegetables cook, their natural sugars are released. This causes the veggies to caramelize. The flavors deepen and become more complex. The technique is called mirepoix. It's a French culinary term for a sautéed mix of aromatic vegetables. The mirepoix is very substantial to add both texture and flavor to this veggie burger recipe. They add the final ingredient, the mushrooms. And after more mixing and cooking, this veggie burger mirepoix is complete. They transfer the mirepoix to a big mixing tub called the gondola. And now they add the dry ingredients. They include walnuts, cooked bulgur, oats, potato flakes, and pure gluten flour. The worker adds pails full of each of these ingredients to the mirepoix. Then, using a shovel, he folds all the dry ingredients into the mix. Moistened by the cooked vegetables, the gluten flour becomes sticky. This causes the ingredients to cling loosely together, taking on a consistency similar to that of cookie dough. He now loads the sticky mix into a hopper that leads to an automatic patty-making machine. It's a mold with a plunger-like mechanism that presses and shapes the mixture into perfect patties. A constant spray of water keeps things from becoming too sticky, allowing the patties to be cleanly ejected from the molds. Then it's a short conveyor trip to the next station, where workers retrieve the veggie patties and arrange them on baking trays. In the process, they inspect the patties and confirm that they've been perfectly formed. They roll stacked trays of burgers into a preheated convection oven. When the oven door closes, the burger-laden trays rotate inside so they cook evenly. After baking, they quickly freeze the veggie burgers to lock in nutrients and preserve freshness. Workers then load the frozen veggie burgers onto a conveyor, and they head up into the packaging line. These burgers can't spend too much time outside the freezer, or they'll start to thaw. A hot iron seals the cellophane wrap around groups of 4 burgers and separates them into packets. Down the line, suctioning devices open cardboard boxes and transfer them to a conveyor. The boxes are now positioned to receive the burger packets. As they move forward, workers just slide them inside. The boxes of veggie burgers then head into a narrow lane to close the pre-glued flaps. This entire packaging operation takes less than a minute. In just 1 hour, this factory can wrap and package over 9,000 veggie burgers. At the end of the day, that's a lot of meatless burgers. But it should be enough to feed a growing trend of vegetarianism. Used for centuries to drill holes for pegs and bolts, augers have played a big role in history and were critical to the construction of everything from tall ships to manor homes. Traditionally rotated by hand, today's power drills give the auger bit a more modern twist. Attached to a power drill, an auger bit can chew through wood in seconds to produce perfect screw holes. It spits out shavings through the corkscrew-shaped pathway, preventing it from clogging the freshly drilled holes. Operated manually or by drill, the auger bit is an efficient gizmo responsible for a lot of projects coming together. An auger bit starts as a solid steel rod. They heat it to a blistering 900 degrees Celsius. When the rod is white hot, it's supple enough to be shaped. He moves one end of the hot steel rod under a long pulsating hammer. The anvils below allow the energy of the hammer to be transferred to the rod and flatten it. He angles the flattened end sideways to shape the edges. He then tweaks the profile a bit more by moving the rod from anvil to anvil. The anvils are set at various heights for impacts of different force. When he's done, the once circular steel rod looks like a long putty knife, but this is just temporary. Next, it's back into that super hot furnace to reheat the forged end to a malleable state once again. He clamps the white hot rod in a machine that twists the flattened end to a specific configuration. In this hot and supple state, the steel is as easy to twist as a piece of stiff ribbon. As the steel cools, it becomes more rigid, so it's back into the furnace to make it pliable once again. He places it between the jaws of a toothed vise. He closes the jaws repeatedly as he pulls the auger along. This crimps the auger spirals to a precise configuration. Each spiral ends up exactly the same. It's a critical step. Without it, the auger wouldn't operate smoothly and could even get stuck as it drills through wood. Now he slams a drop hammer onto the tip of the auger repeatedly, forcing it into a die. As the hot steel fills the die cavity, it takes its shape, giving it the rudimentary profile of the drilling head. It's now tapered like a cone, but there's a lot of surplus material surrounding it. This surplus steel is a bit of spillover. He trims off that hardened spillover with a clip press, and this further defines the drilling head. He presses the auger tip against a ridged grinding wheel to carve a screw thread into it. The screw thread will give the auger bit extra bite as it drills through wood. The focus now turns to the other end of the auger, the shank. As it spins in a lathe, cutting tools slim the shank and shorten it to precise specifications. Now they toughen up the steel by first heating it and then dipping it in cool oil. The shock caused by the abrupt temperature change makes the steel harder. Then the auger spins between two wheels. One wheel rolls it, the other grinds the outer diameter of the twists to specification. A worker grinds the valleys in the auger twists by hand in order to reach every spot. This smooths the surface so wood shavings will flow upward as the auger bores deep into the wood. He changes the belt to a finer abrasive and preps it with a small stone. He spins the belt and polishes the auger until it shines. And the result is a glossy sheen. It looks good and will further smooth the way for the extraction of wood shavings through the twists. Now with a different and much smaller grinder, he carves wings and sharp edges below the auger's cutting head. From a simple steel cylinder to a useful wood drilling bit, this has truly been a story with many twists and turns. With the work at the factory now done, these augers are ready for any job. They come in a range of diameters and lengths for tasks of any size. With so many options, all those projects should come together bit by bit.